Good evening, everyone. Let's go ahead and start. Today, we will focus LangChain agents middleware. This is one of the famous concept. We till today or till yesterday, we developed many LangChain agents, right? Till yesterday, we developed many LangChain agents. For example, this is how we developed the agent, right? We imported the environment variables or loaded the environment variables. After that, imported the necessary libraries, then initialized the model or LLM. After that, we created an agent. Then we invoke the agent by passing the prompt. And when I run this particular application, and we are getting the response. So this is how we created the agents. This is how we created the agents till now. So these are all created using LangChain. Today we are discussing LangChain agents middlewares. What is a middleware? We'll understand now. Till yesterday, we developed many agents, many LangChain agents like this. Now, if you see the architecture here, okay, if you see the architecture here, there is a user. That means we inputted the prompt that went to the agent. Now agent is giving the response and we displayed. So that means the flow is, architecture flow is for this program, for this application, the architecture flow is user, then there is a agent which is doing all the magics and response and providing the response. What agent is doing here? What agent is doing here? It decides the actions, call the tools, invoke the models, and so on, so on. So if you see the agent, whatever we have here, what it will do? It decides the actions, call tools, okay, invoke models, like that. It will do the many actions. That is what the architecture flow right now. So that means here there is no middleware. If no middleware, okay, if no middleware, then the flow is like this. If no middleware, then the flow is like this. So that means between user or user agent response, user input. User means input, prompt. Okay, so user means input, prompt. So there is a user input, then agent response. This is what the architecture we have. So here agent is the one which will do. Okay, so agent is the one which executes all these things like a tools, models, actions, then it will give the response. It will give the response. This is what it is. Now the question is, you can see user is inputting. User is inputting and it will go to the agent and we will get the response. So that means there is lots of data exchange. There is a lots of data exchange between, okay, between first one, user input to agent, okay, user input to agent, and the second one is agent to output, agent to response. That means output. There is a lot of data exchange between user input to agent, agent to response. Response means output. Now, do you think that whatever we pass, let's say we are passing some sensitive information, card information, whatever we pass, directly give to the agent, or it is better to interrupt and do validations? It is better to interrupt, do validation, then send to agent. So now the question is, there is a lot of data exchange between user input to agent, agent to response. Now the question is, do you think that we can pass all the data directly, or we can pass all the data directly, or interrupt? So there is a user data, it is going to the agent, or okay, interrupt. INTERRUPT, interrupt in between and do validations. Okay, do validations or logging or something, then pass, then continue. So what is the good approach? Let's say we have a sensitive data. Assume that we have a sensitive data. Okay, assume that we have sensitive data. Sensitive data means, let's say we are passing card data. Okay, so we are passing credit card data like that. So when we pass the card data, let's say here we are passing the card data. So can we pass directly, or it is worth to interrupt in between, do validations, log in and do like this and continue? Yes, definitely this is a better approach. Okay, so please try to understand. We have written so many agents till now. What is the architecture flow right now? Here there is no middleware, definitely. Here there is no middleware, definitely. So therefore, whatever you are entering, going to the agent is doing some actions, okay, calling the tools, models, and giving the response. This is the architecture. So that means in between there is no interruption. In between there is no interruption. Okay. Now the question is, there is a lots of data exchange between user to agent, agent to response, agent to output. Now, do you think that we can pass all the data directly between these layers? Okay, between layers, or it is worth to interrupt between. Let's say user is entering something, do validations, check proper data, proper input, then hand over to agent. So therefore, interrupt in between, do validations, logging for monitoring purpose, and so on, so then continue. Definitely, this is the good approach, because you might be passing some sensitive data. Sensitive data, it is always worth to validate once, log once, or you cannot, sensitive data you cannot log directly. So mask it, log it like that. In a simple word, it is worth to interrupt in between, do validation, change the behavior, modify behavior. Okay, so interrupt in between input and output. So there is a input and there is a output also, right? So do a interrupts between input and output. Okay, do the validations, modify the behavior. Okay, log the information, and perform some security things and continue. Yes, definitely this is the good approach. Definitely this is a good approach. That's why I'm putting in the green color. So whenever there is a sensitive data, it is not worth to pass directly between the layers. Do some kind of security things. Do some kind of validations. Change the behavior if required. Okay, so assume that this is one layer, this is another layer, and this is another layer. So these are the different layers, right? These are the different layers. Is it worth to pass the data between all these layers directly? Is it worth to pass the data between all the layers directly? Definitely no, because there can be some sensitive data. So do validations, provide security, change the behavior, modify the behavior, do interrupt, like that, do many things, then pass the data. So there is a lots of data exchange between input to user, input to agent, agent to output, like that. Do you think that we can pass all the data directly between these layers? Yes, you can do it, but that's not a best approach. We can do this here, but that's not a best approach. That's why I'm putting little red color. Then what we can do? So interrupt between the layers. Interrupt between the layers, like an input layer, there is output, in between, interrupt it, do validation, provide security, log the information whatever needed, modify the behavior, and continue. This is the best approach. This is the best approach. Now the question is how to interrupt it in between. How to interrupt in between layers. So the answer is using middlewares. So the answer is using middlewares. Now you understood what is the meaning of middleware, right? Now you understood what is the meaning of middleware. So if you see, we have developed so many agents till now, and there are no middlewares. If there are no middlewares, how the flow, general flow, user is trying to input something, it will go to the agent will do all the necessary things, calling the tools, okay, invoke the models, all these things, then finally we get the response. Assume that this is a layer 1, layer 2, layer 3, and can we pass the data between all these layers directly? Yes, you can do it, but that's not a worthy one, because data might be sensitive. If the data might be sensitive, it is always good to interrupt between the layers and do the validations, do the logging, modify the behavior, and continue. Then how to do that? How to interrupt between the layers? By using the middlewares. By using the middlewares. Now the question is, what is agent middleware? Okay, if anyone asks a question, what is agent middleware? Now you understood what is the middleware, right? Middleware is a layer, is a code basically, is a layer that sits between the agent and its execution environment. Execution environment. Okay, that sits between agent and its execution environment. What it will do? Okay, so it intercepts. Okay, so it interrupts or intercepts. Okay, so it intercepts. Okay, so it intercepts between layers. It intercepts and modifies the flow before before or after agent execution. We'll see the examples. Before and after agent execution. So you can see this is the agent, right? If you see the flow, this is the agent. Before agent, I want to do something. After agent, I want to do something. Then middlewares can help. Okay, before sending the data to agent, before agent actual execution. So I want to do something. I want to validate it. I want to print it. I want to log it. After agent, I want to get the information, display it, massage it, do some hiding like that. Then we can go with the middlewares. So that's why if anyone asks a question, what is a middleware? It's a layer. It's a code. It's an additional code. That's it. It's a layer. It's an additional code. Sits between the agent and its execution environment. And it intercepts or modifies. It intercepts and modifies the flow when before and after execution of the agent. When before and after execution of the agent. That's why if you see the flow diagram, this is how the flow diagram will be. You can see the flow diagram, please. Yes. So this is a nice understanding whatever we discussed till now. Let me take this into Paint. This is a nice understanding whatever we discussed till now. So please remember this. We are learning lots of new terminologies. Try to adjust with the new terminologies. Okay, digest the new terminologies so that you will be learning a lot. Okay, so far, okay, you can see this one, please. So far, we did not use the middlewares. Without middlewares, we developed the agents. Then how the architecture flow? So user inputted something that is going to the agent. Now agent will do all the necessary things like calling the models, okay, tools, actions, all those things. Then finally we get the response. This is the architecture we have till now. Our high level architecture we have till now. Good. Then I said, is it worth to pass? Assume that this is one layer, this is another layer, this is another layer. Is it worth to pass the data directly between the layers? That is what we are doing till now. Yes, it is okay, but not that worth, because data can be sensitive. If the data can be sensitive, then before going to the model, I want to do something. Before going to the agent, I want to do something. After agent execution, I want to do something. Then how to do that? Using middlewares. So that's why I said middleware is a layer that sits between agent and its execution environment. It intercepts, it modifies, okay, the it modifies the flow before and after agent execution. Before and after agent execution. That's it. So that's why now assume that you are developing, okay, assume that you are developing a agent with assume that you are developing a agent with middlewares. Assume that you are developing a agent with middlewares. If you are developing agent with middlewares, so you can see user input, that layer will be as is, response, that layer will be as is. Okay, user input, response, those layers are as is, and the agent also as is. These three as is. Now you are writing a middleware. That means additional code, extra code, another layer code that sits before agent, after agent. So that's why before agent, after agent. Okay, so before execution, you want to validate something, you want to log something, you want to do something, then you can do it. After execution, okay, after execution, then you want to log something, you want to cache something, you want to do some validations, then you can do it. Then you can do it by using middlewares. So before execution, after execution, you want to do something. This is how the architecture flow if you are using the middlewares. In a simple word here, we will have the same code whatever we have written till yesterday. Then we will write additional code before agent or before execution, after execution. So we intercept request, we intercept the response. After execution means we get the response, right? That's why you can see intercept the response, intercept the request. Before agent means intercept the request. After agent means after execution. Before execution means request, whatever you are sending. You can intercept, you can print it, you can validate it. Okay, after execution. After execution means you have the response. That response you can intercept, you can modify, you can log it, you can change it, you can cache it, and so on, so on, so on. In between, so the agent get executed, agent runtime. Agent runtime means what? That executing the tools, invoking the models, all those things. So therefore, before completion, before execution, you can take care of the request. After execution, you can take care of the response. Before execution, you can validate the request. After execution, you can validate the response. Before execution, you can print, you can do massaging of the request information. After execution, you can print, you can massage the response information. That's the middleware is. That's the middleware is. Now I told you what is the middleware, agent middleware. You can see agent middleware is a layer. It's a code sits between agent and its execution environment. And it intercepts, modifies the flow before and after agent execution. Before agent execution, what it will intercept? Request information. After agent execution, what it intercept? Response information. We'll practice it here. Then what middleware can do? Just now I told, right? It intercept input and output, modify the behavior, log it, provide security, validations, control the usage, tool usage, control the tool usage. That means based on the data, I can tell go and execute this tool. If weather data is coming, call the weather tool. If the some other data is coming, call that tool. And I can also say if the bad data is coming, don't call the tools. That means you can control the tools also. You can control the tools also. That's the importance of this middlewares. We'll use middlewares a lot here. We use middlewares a lot. That's why this is the important concept. Now you can see whatever we discussed is available here. Okay. So middlewares wraps between agent execution. That's what I told. This is the agent. So it can be before, it can be after. Then it intercept, modifies, allows, blocks, enhance the request and responses. That's what we discussed just now. So before agent execution, I want to modify the request. I want to print the request. I want to handle the data. Then you can do. After execution, you get the response. You want to handle it. You want to print it. You want to convert into JSON. Let's say plain data is coming. You want to convert into JSON. Like that, you can do all the massaging. Then multiple middlewares are possible. Okay, so that also possible. Next, one more point is if middleware does not call handler, remember this, when we code it, we can see. If the middleware does not call handler, then it stop the execution. Okay, that means the agent will be stopped, tool will be stopped, model will be stopped, it will not run. What is the meaning of if middleware does not call handler of request? So we will see in the code. Okay, we'll see in the code. So therefore, whenever you are writing the middleware, it is your responsibility to call handler of the request. If that is not there, then it will stop the execution. Whatever execution is done till that moment, it will stop it. What that means, we will understand when we read the code. Next, middlewares invoked around the model calls. Okay, agent steps. That's it. Then middleware, that's what I just now we discussed, right? Middleware must call handler of the request. If this is not called, then whatever done till that moment, it will stop. It will not continue. It will not continue the chain. It will not continue the next execution, and so on, so that's why this is important. Then why to use middlewares? Why to use middlewares? We can validate the, okay, so we can validate the inputs, we can validate the outputs. Okay, then we can log the information, we can do the caching, we can do the caching. Okay, we can specify which tool to execute, which tool to not execute, allow the tools, deny the tools. Okay, then we can prevent some of the information. Then cost control, budget, because you are not passing all the information, so it can also reduce the cost. Like this, we have n number of advantages. Now this is the flow. So right now agent.invoke is there, right? So till now this is how we created the agents. So agent.invoke. When we have a agent.invoke, after agent.invoke, middlewares come into the picture. Before middlewares come into the picture, then agent execution, then agent execution, then after middlewares running, after middleware will come into the picture, then final response. So that means after this invoke, okay, so we write the invoke, then middleware should come into the picture. That middleware is executed before middleware. We call it as before middleware. Then agent, after middleware, then response. These are the high level steps. So that's what it is. Now you can see what is the agent middleware. It's a layer code. It's a controller code. Intercepts, enhance, governance the agent execution. Whatever we discussed, these are the different points covered here. That's about this middleware. In a simple word, middleware is a code. It's a layer, sits between before agent execution, after agent execution, and we can do validations, caching, okay, intercept, change the behavior, modify the data, and do a lot in the real time also. That's why these middlewares are very important. That's why these middlewares are very important. That's about the introduction. That's about the concept of middlewares. Now you can see one more picture here. You can see one more picture here. You can also go to the google.com and type LangChain, okay, middlewares. You can type LangChain middlewares. You can see the documentation. You can see the documentation. These are all the different documentation about the LangChain middleware. Okay, LangChain agents. Then we discuss a LangChain overview. We discuss LangChain agents. Till now we completed creating the agents. Then we are discussing the middlewares. There are so many out of the box middlewares also. We'll cover it now. Okay, so that's how you have the documentation. You can refer this official documentation also. But no need to go this much of official documentation. You can simply read our documentation because we already given everything here. We already given everything here. We summarized it. We massaged it, everything here. We summarized it. We massaged it, everything here. Now you can see this one, please. So this is how we are writing the agents, right? This is how we are writing the agents. Let me execute this agent creation. So this is how we have done till now. I'm just executing this once. I'm not invoking. I just created the agent. I'm trying to execute it. Now this is the flow, right? So it will start, then it will go to the model. If there are tools, it will execute the tools. If there are no tools, it will stop it. Okay, so this is the architecture. So therefore, agent loop architecture. First, it will come here. It will go to the model. It will identify what are all the tools. Then tools get executed. If no more tools, it will give the results and it will end. If no more tools, it will give the results and it will end. That's what we have seen before. Okay, so this is what we understood before and we have printed many times. So this is the general flow. Now, what this middlewares will do? As I said, right, middleware exposes hooks before and after. So that means you have a request and you have the response, which is nothing but results. Between request and response, between request and results, you can put all these different hooks. You can put all these different hooks. Before agent, after agent, what to do. Before model, after model, what to do. Okay, so there are two things basically. You can apply for tools, you can apply for models. Tools are nothing but functions, right? Before tool, you want to do something. After tool, you want to do something. Before model, you want to do something. After model, you want to do something. Then you can see wrap tool call. Wrap tool call you can use if you want to do for tools. Wrap model call. This is what you can use if you want to do something for the models. So that means before model you want to do something, after model something you want to do. Before tool call you want to do something, after tool call you want to do something. Then these things we can use it. This is the high level flow. So let's recap this one please. Whenever we create the agent, what is happening? Whenever we create the agent, there is a request. Request will go to the models. Then model will decide are there any tools. It will go and execute the tools. It will go and execute the tools. No more tools. Then it will finish it. It will give the results. This is the general flow. Now in between we can put the middlewares. Okay. So now we have a agent here. So before agent, after agent, what to do? You can specify. Then before model, after model, what to do? You can specify. Okay, so before agent, after agent, what to do? You can specify. Then you can say that wrap tool and a wrap model. So that means a wrap tool, a wrap model, wrap tool call, wrap model call. So like this, we can use all these different annotations or hooks. You can call it as hooks to perform different activities at different steps. Different activities under different steps. That's it. If you want to understand the layman terminologies, if you want to understand the layman terminologies, what is the middleware? If you want to understand the layman terminology, what is the middleware? You can see the flow here. Let's say customer came. Okay, let's say customer came and placed the order. Let's say customer came and placed the order. When customer came and placed the order, chef is the agent. Chef is the agent, and in between chef and customer, there is a supervisor. He's like a middleware. Between chef and customer, there is a supervisor. He's like a middleware. What that middleware? What that supervisor do? He will validate. He will check the condition. He will check the taste, ingredients like this. So you can visualize supervisor is like a middleware. In the kitchen example, if you take, so there is a restaurant example you take. So when you go to the restaurant, you means customer, place the order. Then chef is the one who cook that. Between customer and the chef, there will be a middleware called a supervisor. What he will do? He will keep monitor the ingredients, taste, okay, verify all those things. That's why supervisor validate it. Okay, so then what he will validate? He can validate the tools, means appliances, and he can take the supervisor, take the feedbacks, and so on, so on. So finally, this is served. That's the output. So in a simple word, your restaurant supervisor is nothing but a middleware. He will do lots of activities. He will verify the ingredients. He will verify the taste. Okay, he will verify the appliances. All these things. That's called a middleware. So therefore, this middleware, this supervisor ensures that okay, ingredients are correct, quality is good, no mistakes are done. That's it. Now we have different for safety purpose. We have uh, guardrails. For observability purpose, you can do the logging. We'll practice all these things: guardrails, logging, retry, performance, okay, state, memory. We already seen. Like this, we have different things which we will practice it. Next, okay, that's about this picture. We are discussing all these things. Now the next one is okay. Now we understood what is the meaning of middleware. It's a layer. It's a piece of code which sits between agent and its execution environment, and we can do some kind of validations, verifications, security, all those things. That's it. Then, so if anyone asks a question, what is middleware responsibilities? Just now we discussed, right? What is middleware responsibilities? Just now we discussed. Okay, validation, input validation. Okay, then we can do the logging. We can do the observability. Okay, so third one is what? You can do the tool controls. So you can stop particular tools. Then guard rails. We'll see what is guardrails in the coming days. Okay, guardrails we'll see in the coming days. Okay, then error handling. We can do error handling because of the middlewares. Error handling. Then what else we can do? State enrichment. We can enrich the state. That means data. Like this, we can perform n number of activities because of the middlewares. If anyone asks what is the middleware responsibility, minimum you should answer this. Then we have different middleware types, right? So middleware types. Just now we discussed. What are the middleware types? Okay, pre-processor middlewares. Pre-processing. Okay, middlewares. Pre-processing middlewares. That means before. Okay, before models. So pre-processing middlewares means what? The meaning is inspect or modify input. So this is a pre-processor, right? Means okay, before agent. So therefore, pre-processing middlewares. So inspect or modify input before the models runs. Before model runs. Obviously, right? This is the pre-processing. If you see this diagram, okay, so if you see this diagram, where is this diagram? Okay, let me put into the paint. This is what we are discussing. Pre-processor middlewares before. So before means request, right? Okay, so therefore that's why inspect or modify input. Input means request data before model runs. So if a pre-processor is there, then the next one is post-processing. Post-processing middlewares. Post-processing middleware obviously do what? Output, right? So therefore, validate, filter, you can do all these things. Filter, modify, modify what? Models, response, in bracket, output. So therefore, pre-processing middlewares, post-processing middlewares, and tool middlewares. Okay, tool middlewares. That means these are related to the tools. So that means function callings, right? So inspect or approve or reject or modify what? Tool calls. All results. So we have created so many tools, right? You remember weather tools, okay, web search tools, Tavily tools, like that we have done so many tools. So then you want to inspect, you want to modify, okay, you want to modify the tool calls, then we can use tool middlewares. Then there is a gradual guardrails, GUARD, guardrail middleware. What this we will do? So before model you want to do something, pre-processing middleware. After model you want to do something, then post-processing middleware. With the tools you want to do something, tool middleware. Then guardrail middleware. Guardrail middleware means apply, okay, apply safety, okay, policy, compliance rules, okay, compliance rules. These are all will be applied. So that's the purpose of guardrails. We will practice all these things. So for now, you need to remember what are the different middlewares we have. Okay, so middleware types we have. For that, pre-processing, post-processing, tool related, and guardrail related, and logging. Okay, so logging or observability related middlewares. Related middlewares. Like this, we have different middlewares. What is the purpose of this login middlewares? So collect the logs, metrics, okay, traces, all these things. Traces, all these things. That's it. That's it. Now, in a simple word, logging middleware, you can visualize this one like this. LangChain plus agents plus logging middleware. If you are a Java person, this is equal to, in Java, we have log4j. You can visualize like this. So therefore, LangChain agents with logging middleware. LangChain agents with a login middleware, you can visualize your Java technology log4j. You can visualize your Java technology log4j. That's it. You can visualize your Java technology log4j. That's it. Like this, you can visualize it here. Like this, you can visualize it. That's about different types of middlewares. So pre-processing middlewares, post-processing middlewares, tool middlewares, guardrail middlewares, logging middlewares. Agents, LangChain plus agent plus logging middlewares equal to your Java technology log4j. All right. Now, so we have seen, so like this, we have so many concepts. Let's see some more concepts. We have seen many concepts till now. There is a agent concept. Okay, so there is a agent concept. There is a tool concept. Now we are understanding middlewares. Then there is a callback handlers. There is a callback handlers. Then we have a guardrails. Okay, then we have seen memory. Then we have seen checkpointers. Like this, we have seen many concepts till now. Out of all these things, callbacks handler, guardrails, we need to see. So what is the purpose of guardrails? You can start remembering. Guardrails enforces, okay, enforces the policies. So that means more safety. Okay. So and the guardrails you can execute before and after, before or after model or tool, model or tool execution, before or model execution. Okay, that's it. Then tools, we know very well. Functions, middlewares, just now we discussed it. Callbacks. Callbacks means if something happen, okay, then what is the callback? Generally we use for logging, tracing, all those things. Okay, then guardrails, memory, we have seen. What is the purpose of memory? Okay, maintain the context or conversation. maintain the context or conversation or messages, like that. Check pointers we have seen, saves the data and restore the execution. Like this we studied many concepts till now. Like this we have studied many concepts till now. Then why do we need the middlewares? Just now I told, right? If anyone asks why do we need middlewares? For the validations, for sanitizations, for logging, okay, for applying safety, reduce the cost. Like that we have seen many advantages. Now we have different concepts, right? Like there is a agent, there is a middleware, there is a tool, all these things. What are the different Java or Spring equivalent terminologies for this? So let me put a small table. So here we have a AI concepts. So here we have a AI concepts. Now these are nearly equal to what? Java or Spring concepts. Okay. So the first one in the AI is agent. So in the Java we have service layers, right? Service layer or orchestration, orchestrators. Those are like agents. If you are a Java person, you can visualize the, okay, if you are a Java person, you can visualize the right side. This is how easily you can learn it. If you are a Java person, agent is like a service layer or orchestrator. Okay, orchestrator. Now, middlewares. Just now we are started understanding the middlewares. In the AI, we call it as middlewares. In the Java or Spring, so we have servlet servlet filters. Okay, Spring interceptors. Okay, like this. So these are equal to middlewares in the AI. These are equal to middlewares in the AI. So if you are a Java person, don't think that you are learning too much new. No, you can visualize middlewares are like a servlet filters. You can visualize middlewares are like a Spring interceptors. Okay. Now you are a Java guy or you are a Spring person. Agent, don't think that you are learning too much new. In the Java also, in the Spring also, we have done the orchestrator. You have done the service layers. Those are like agents. Then in the AI side, we learned the tools. Tools are nothing but what? Functions. In case of Java, it's like a DAO. It's like a external API. It's like a service client. That's it. Then we understood the memory. So if you are a Java guy or a Spring person, you can visualize memory is like a session context or cache or conversation context. Okay, so in case of Java Spring also, we have done the memory concepts like a session context, a cache, conversation context, like that. Same thing in the AI. Next, check pointers we understood. Check pointers. Okay, so if you are a Java person or Spring person, you can visualize check pointers like a workflow state persistence. Okay, workflow state, okay, persistence or save point. Like this, you can visualize it. Then we just now we are discussing a new terminology, callback handlers. Okay, callback handlers. Now don't think that you are learning too much new in the AI for the callback handlers. Callback handlers in the AI is similar to your Java event listeners or AOP or observers. Okay, observers. In the Java Spring also we have observers, AOP, okay, AOP or event listeners. Those are similar to your AI concept of callback handlers. Then just now we are saying guardrails, right? GUARDRAILs, guardrails. Then in the AI, it's a guardrails. If you are a Java person or Spring person, you can visualize this is like a validation layer or security layer. or policy environment layer. Like this you can visualize so that you will not feel that you are learning too much new. That's it, that's it, that's it. That is how you can correlate with your existing technologies. That is what exactly you are doing. Guardrails is like a validation layer, security layer of your Java, your Spring. Like that, you can correlate your current concepts with your previous knowledge. If you are a Java person, if you are a Spring person, and so on, so on, so. That's it. So the next question is, if you see the documentation, we are discussing the middlewares, right? Then we understood the middleware overview. So this is what we understood, right? Request, model, then tools, results. Then in between there are so many things. This is what the diagram just now we understood. We will code it one by one. Then then middleware. Middleware is nothing but what? Piece of code which can put before and after and to do some kind of validations, all those things. LangChain by default provides lots of predefined middlewares. Okay, you can see here LangChain by default provides predefined middlewares. Predefined middlewares. LangChain by default provides LangChain for agent purpose, for deep agent purpose, by default provide predefined, pre-built middlewares. Pre-built middlewares for common usages. What are those? You can see there is a big list. You can see there is a big list here. And I just mentioned, let's go through the notes once. This diagram we discussed, this picture we have discussed, these things we discussed. Now I said LangChain or LangChain and deep agents provides a predefined this middlewares. So you can see the list. There are so many. So the first one is summarization middleware. You can just have a look at this quickly. You can just have a look at this quickly. Summarization middleware. So summarization middleware means it summarizes the conversation. So compress the long conversation into shorter. This is very important, right? Because if you go to this chat GPT, if you go to the chat GPT, you type the question, you get the answer, question, answer, question, answer. So that means there is a lots of there is a lots of data, there is a lots of conversation exchanged. So if you are keeping as is without summarization, then tokens are increased. Tokens are increased means cost increased. That's why summarization is important. So for summarization purpose, we have a summarization middleware. Then HITL middleware. So sometimes what happen, let's say you are trying to send an email. Before sending the email, you need the approvals. Then you can go with the HITL, human in the loop middleware. Okay, human in the loop middleware. Okay, next model call limit. So we understood that there is a limit in the number of tokens, right? So therefore, you want to do some magic, you want to do some logic, you want to write something, then we can use model limit, model call limit, limit maximum number of, model call limits means, whenever we give the prompt, let's go to here. So this is the prompt. When we give this prompt and do a invoke, there is a model call. Now you want to limit the model calls 5 times, 4 times, 3 times like that. Then we can use model call limit. Limits maximum LLM invocations, model invocations. Okay, that's it. Then tool call limit. Tool call limit also same. Now we have a tool call, right? Like a Tavily tools, okay, web search tools, okay, weather tools like that. So you can put the limit. Limit how many times you ask an expert. 3 times, 2 times like that. Then model callback the middleware. These are all provided here. We can use it to do some high level coding or to change the behaviors. Then pH detection middleware. Sorry, not pH. PII, personal information This one. So for this also we have some middleware. For this also we have some middleware, PII. Then planner middleware, tool retry middleware, model retry middleware. Like this we have different file search middleware, sub agent middleware, shell tool middleware. Like this we have different out of the box provided pre-built middlewares. We can use it to change the behavior. Sub agent middleware means what? Delegate the some part of the work. Delegate some part of the work. You can also call it as middleware components. So if anyone asks middleware components, you can tell this. So therefore, sub-agent. Sub-agent means what? Agent will do the task, right? What is the agent? Okay, entity that acts. Then sub-agent means take some part of the work and do it. Take some part of the work and do it. That's why delegate part of the work to another agent. Another specialized agent. We call it as sub-agent. Like a manager assigning the work to the developer. Manager, development work he will assign to the developer. Okay, testing work he will assign to the tester. Performance related he will assign to the performance people. So that means he delegate the work to the respective specialist. Okay, and so on, so on. So like this, we have lots of predefined middleware components. Okay, so we can use this, or we can also write our own middlewares. That's why if we go here, custom middlewares. If we go here, custom middlewares, we can write our own middlewares. This is what we need to start our journey. So therefore, in LangChain, we can custom middlewares. Custom middlewares means what? Built custom middlewares. So that means we can implement it. Okay, so we can implement a custom middlewares. We can write. Okay, we can write custom middlewares. How? We can write custom middlewares. How? For that, we have two styles of. Okay, so two styles of hooks. For this, the answer is um, we have two styles of hooks. For this, we have two styles of hooks to intercept the agent execution. So for custom middleware purpose, we have two styles of hooks. We have two styles of hooks to intercept the execution. To intercept the agent execution. What are those two styles? So the first one is, okay, node style hooks. What are the node style hooks? At before agent. Okay, then at before model. Okay, at before agent, at before model. Then at after agent. Okay, at after model. Like this, we have different decorators. We call it as decorators. So to implement node style hooks, we have decorators like a at before agent. So that means before agent means what? This will run once before agent execution. At before model. That means this runs before model invocation. After agent means this will be executed after each after agent execution completes. After model means what? After each model response. Like this, we have different decorators. We can use it to perform the specific logic. How? We will code it, but just remember that there is a before agent, before model, after model. These are all like a decorators. These are all decorators for node style hooks. Similarly, there is a wrap style hooks. WRAP, wrap style hooks. Okay, so then how do I implement this? This we can implement it at wrap underscore model underscore call, and we have one more thing at wrap. So model then tool underscore call, like this we have. So therefore this is applied around the model, this is applied around the tool. So therefore total we have 6: before agent, after agent, before model, after model, before wrap model call, wrap tool call. So this will be around model, this is around tool. So that means so then let's understand what is the meaning of node style hooks. Okay, node style hooks means run automatically. Okay, run automatically at predefined lifecycle events. Okay, so these runs automatically at a predefined lifecycle events. That means, so now we have wrap style hooks, right? Wrap style hooks means what? These wrap execution around the model or tool. Okay, model or tool, around the model or tool, model or tool. So you can continue, retry, modify all those things with this wrap. We'll practice the examples of this. In a simple word, you can remember if you want to write a custom middleware, we have two styles. Okay, node style and wrap style. Node style means automatically applies, runs automatically at predefined lifecycle events. And this wrap style is wrap the execution around the model. That's it. That's it. Now we will see the examples of this one by one so that we can understand it. That's the overall concepts of middleware. Now let me show you the nodes once. Then we can start the coding. Let me show you the nodes once, then we can start the coding. So as I said, right, LangChain for the deep agents purpose provided the lots of predefined agents, predefined middlewares or components. You can see that list here I provided. Then custom middlewares. We can also build the middlewares by implementing the hooks. So we have two types of hooks provided. So first one is node style and another one is wrap style. Node style, we have different decorators: before agent, after agent, before model, after model. Wrap style, we have two decorators. So at wrap model call, at wrap tool call. And if you are using this before agent, after agent, before model, after model, those runs automatically at a predefined lifecycle events. And you cannot skip this, can't skip this. Okay, so then before agent, after agent, before model, after model, you can use for logging purpose, metrics purpose, validation purpose and all. Then wrap style, when can we use? So wrap means you are going to perform around the model. You are going to perform around the tool. Okay, that's it. So then these are best for retry, caching, okay, timeouts, okay, output transfer. Let's say you are getting output in some format, you want to transfer to some other format. These are all we can do with the wrap. That's it. That's it. Okay, so then there is one more question: execution order. So we have two things, right? Node style, wrap style, execution order. So we have before hooks, after hooks, then wrap hooks. Before hooks, wrap hooks, and after hooks. So then what is the execution order? First, before, after, then wrap. So before is like a first to last. So that means whatever we have registered in the same sequence it executes. After means last to first, reverse order. So that means you mentioned 1, 2, 3, then 3, 2, 1 is the execution order, last to first. Then wraps are nothing but like nested. So inside this one execution, inside that another execution, inside that another execution, like this. Okay, that's it. Then how can middleware skip another execution state? So we have end, stop the execution immediately. And there is a model jump directly to the specific model. There is a tool jump specific to the tool jump. So therefore, if you want, so the question is, how can middleware skip another execution stage? For that, we can use end, which will stop the execution immediately, or model jump to the specific model execution node, tool jump to the tool execution node. Like this, we can use a different decorators. Like this, we can use the different decorators to perform the different activities. Different activities. Now we discussed enough concepts. Now let's do the coding. Let's do the coding. We'll practice the exercises. Now we have different middlewares, right? So pre-processing middlewares, post-processing middlewares, tool middlewares, guardrail middlewares, logging middlewares. Let's code. Let's start with the logging middlewares. Okay. So scenario one. Scenario one. Okay. Create logging middleware and display it when create agent. Creating agent. So this is the scenario. So create a logging middleware. Create a logging middleware and display it. Logging means like a logging information. Okay, and display when create agent. Display when create agent. So that means whenever you are creating agent, there is a before agent, after agent, right? If you go back to our execution, or if you go back to our picture, so this is the one, right? Let me copy this and put into the paint. So let's say this is the agent. Okay, so before agent, after agent, before agent, after agent, I want to apply the login middleware. Okay, so here I want to apply login middleware. Okay, login middleware. Okay, so this is before. Similarly, I want to apply login middleware after. Okay, login middleware after. So therefore, after. This is before. This is the requirement. So that means before what do we have? Request. After what do we have? Response. Before what do we have? Request. After what do we have? Response. So before what do we have? Request. After what do we have? Response. Okay, so before what do we have? Request. After what do we have? Response. So in a simple word, so before agent, we have the requested information. Okay, we want to log it. Okay, after agent execution, so we have a response and we want to log it. So how? Using logging. How? Using logging middleware. That's it. So using logging middleware. So before agent execution, after agent execution, I want to display the information. I want to log the information. Okay, log the information, log the information. That's it. That's it. That's it. Okay, so now let's see the coding for it. Let's see the coding for it. And one more point you need to remember is, strongly is, okay, so now we understood the requirement, right? So before agent, I want to log something. After agent, I want to log something. That's the requirement. Before agent execution, I want to log something. After agent execution, I want to log something. So for logging, we can use a logging middleware. So that's what we are planning to use. So now if you see the code, so this is what we are writing, right? Line number 22, agent.invoke. So this point you need to remember forever. Whenever we call Okay, whenever we call this, okay, so whenever we call this internally, okay, request, request, request object and a handler object, two things. Request object, handler objects are created. Whenever you say invoke, agent.invoke, this point is very important, please understand. Whenever we invoke, whenever we call, whenever we invoke, whenever we call internally, whenever we invoke, whenever we call internally, there is a request object, there is a handler object created. There is a request object, there is a handler object created. Request object holds the message information. Request object holds the message information, and handler, handler, request of handler. Handler will help to call the continuation. We'll see this. So therefore, whenever you want the messages information, you can use request object in a simple word. So that means these are the messages information, right? These are the messages information. If you want a messages information, okay, you can see this is the messages information, right? If you want a messages information, what you can use going forward? Request object. What you can use going forward? Request object. That's it. Now, what is the scenario one right now? Scenario one is create login middleware and display it. When we create agent, that means there is a before agent I want to display something, after agent I want to display something. Before agent, what do we have? Request information. After agent, what do we have? Response information. So request information, response information I want to display. So therefore, whenever you say agent.invoke, internally it creates request object and a handler object. Request object hold all our message information. All our message information. Now let's see the coding for it. So till now, this is how we created the agents. I will copy this and paste it. Okay, I just copied the agent, whatever we created till now. How did we create the agent till now? Okay, load the environment variables, import the necessary libraries, initialize the model, then create the agent, invoke the agent with the prompt. Then execute it, you got the results. This is how we have done till now. Now I want to apply the middleware. When I want to apply the middleware, before agent, after agent. Which middleware? Login middleware. So that's why I will copy the code as is, start writing the changes. So that you will feel that yes, in the existing code only we are keep adding the functionalities. Okay, all right. Now this loading environment variables, load environment variables is same, no changes. Okay, then import the libraries, required libraries, and initialize the model is same, no changes. Till that, no changes. Then what do we need? Whenever we create the agent or whenever we invoke the agent, okay, whenever we invoke the agent, okay, if you see our concept, whenever agent is invoked, then internally request object, response object is handler object get created. And if you see our requirement, the requirement is when agent create. When agent create, I want to call the middleware. Which middleware? Login middleware. So here we are creating the agent. When agent create agent, we want to call the middleware. So that's why, what is a middleware? It's a code. Now let's write that code. Okay, let's write the code. So what is the code? Logging middleware. So what this will do? Display. What is the purpose of this? Display before. Before means request. After means response. In between you have handler. display request response information. That is the purpose of this we are writing. Okay, then if you go back to our discussion, so then which hook I need to use? So you can see we have a before agent, after agent, before model, after model. I want to around the model. If you want to around the model, then go with the wrap model call. I want around the model. Okay, so therefore go to the wrap model. So therefore, what is the hook for it? What is the decorator for it? At wrap underscore model call. At wrap WRAP underscore model underscore call. Now you can see it is giving error. Why? We did not import the corresponding libraries. So therefore, go ahead and import this. So these are all provided by LangChain. So therefore, LangChain dot agents dot middlewares we are using import. Which one we want to import? Wrap model call. Okay. Now wrap model call. You can see the wrap model call code. This is the out of the box code. Anyway, this is not required for now. I will close this. I'll close this. Okay. I just imported it. Okay. So this is the one I am applying here. Okay. Now you can see there is no error. Okay. So wrap model call. So then you can write a function RRRS logging underscore middleware. RRRS login middleware. Okay, so then these will take two parameters. If you see here, if you see the statement, whenever you invoke, there is a request object, handler object, created automatically. Created automatically. So those you take it. So therefore you can say RRRS REQ request object, then RRRS handler. Let me use full names for now. REQUST request and a handler. Like that you are writing a function. Then you can print all the information before and after, right? So let's print the before. Before what do we have? So before we have the request information and the handler information. Anyway, handler information. After you will have response information. So therefore I am just doing around. I am not applying before and after. I am just saying around. That's where wrap. Okay, that's where wrap. So I am not specifically writing before and after. I am not specifically writing before and after. I want to do around. That's why one function, wrap model call. So now you can display print, okay, print request type first. Print request type, comma, type of this request. Type of this request. T is small letter. Type of this request I printed. Next, you can also print the date and time. So when that request is done, print, okay, okay, date and time. Date and time. So for that we can use, okay, date time dot now. So you can need to import it. So you can import from date time, import, okay, date time. Okay, so you can say date time dot now. Okay, so that means date and time when it is requested. Then you can also request the model information. So what model will have? So because you are doing a invoke, right? Invoke always will have the model. So print, okay, model equal to, what is the model? So request dot model. You can say request dot, you will see what are all available. So there is a request date. Like this, you have many request now. You can also use request now. Okay. So request dot. Okay. You can see there is a model. Sorry. Request dot RRRS request dot model. RRRS request dot model. Like this, you can print whatever you want here. Then you can print length also, message length. So print, okay. So request state contains, okay, contains total, comma. So you can say length of RRRS request dot state dot get of that messages, okay, comma. You can pass like this, and you can end this, you can end this, okay. Okay, that's it. You can do all these things. You can print whatever you want here, okay. You can print whatever you want, and you can also print that the last information from the messages. If you see here, this one, okay, last information means -1, right? That also you can do it. That also you can, it's just like a displaying all the information, logging all the information, logging all the information. So request state current message, current message, current message. How you will get messages of -1, right? So RRRS request, okay, dot state of messages, messages of -1, okay. Then you can end this, you can end this, okay. That's it. Like this, you can display all the information. So therefore, now come back here. So before, okay, before model, all these get printed. Now it's time to call the actual model. Okay, so now within this, call the actual model. How? Call the actual model. How? If you go back to our discussion, if you go back to our picture, you can see this point once. You can see this point once. If middleware does not call handler of the request, then execution will stop there. Execution will stop there. So therefore, it's time to use handler of the request. Handler of the request means calling the model. So this is where actual model call happens. This now model call happens. Model call did not happen before. So therefore, how do I do that? So you will get the response. Okay, how do I do that? You can see the syntax, handler of request. So what is the handler? RRRS handler of the request. Handler of the request. This will actually pass the send request to the model. Call the model. Model means LLM. Model means LLM. Call the LLM. That's it. Okay, call the LLM. And LLM call means there is a response, right? That's why RRRS underscore response equal to something. Now you can display the response also. So that means around, before and after. Before and after, I want to display. Before and after model, before model, after model, I want to display. So this you can see, before model we are displaying something, after model you want to display. Then you can print it. Print, okay. So here you said a request type, right? Now type say response type equal to, okay, type of RRRS response. Type of RRRS response. Now you can say what you received. You can also receive response okay, response equal to, you can print that response dot, okay, you can print that response. Like that you can display whatever you want. And you can also print some empty lines. Oh, sorry, some like this into some 56 times. You will get that line basically. That's it. So this is how we have written the wrap. Can you recap this one, please? If you see our requirement, the requirement is what? Create a login middleware and display when agent create. So that means so there is an agent, okay, so which is calling the model. Before model I want to display something, after model I want to display something. What you want to display? Before model means request information, after model means response information. Before model means request information, after model means response information. Okay, so now I want to log it. For log it, we use the logging middleware. So this is how you create it. This is how you create it, and finally return the response also. Finally return the response also. That's it. So this is the middleware logic. This is the middleware logic. Okay, good. Now, now you are creating the agent, right? Okay, this is the middleware logic. Now you created the agent. How? Sorry, you created the middleware. Now, how agent knows you created the middleware? How agent knows you created the middleware? So you need to pass it. So therefore, you can pass middleware whatever you created. You can pass it whatever middleware you created. And I want to do a web search. If you want to do a web search, you need to import the Travely API. So let's say import, okay, LangChain underscore Travely import Travely search. I want to use the out of the box one. I want to use this tool, out of the box tool. I want to use it. So that tool information also you can specify. Tools equal to Travely search. Okay, then you can specify the system prompt. Okay, you can specify the system prompt. What is the system prompt we want? You are expert in doing web search. So how do you do the web search? Using Travely search. Okay, you are expert in doing web search. That's how I did the system prompt. Now this is how I created the agent. When we created the agent, I plugged the middleware also. Which is the middleware? Okay, wrap model. Wrap model. That means before calling the model, after calling the model. So see this. This is what happened internally. So this is what happened internally if I don't write it. Now I am able to capture what is before execution of the model, what is after execution of the model. Before execution of the model, after execution of the model. You want to do something, then go with this. That's it. Then I plugged the middleware for my agent. I plugged the middleware for my agent. That's it. Now you can go here and you can write tell about okay, ChennaReddyTraining in 2 bullets. Tell about ChennaReddyTraining in 1 line. That's it. So this is what I want. Now you can see. So agent.create is so what is the extra we have done? We imported the necessary libraries. Then we initialize the model. Then we have a agent create. For agent create, we passed what is the middleware. The middleware is wrap middleware. Okay, wrap model call. Wrap model call means around the model. Around the model means before the model, after the model. So before the model, I did some logic. After the model, I did some logic. Before model call, I did some logic. After model call, I did some logic. That I plugged with my agent creation. Then I am trying to invoke the agent. I am trying to invoke the agent. Now let's execute and see if there are any errors. There are some errors. Date time. So if you go to the date time, okay, so invalid syntax, perhaps forgot comma. Okay, so why did we have this? We don't need that. Let's execute it. Now, okay, so here you need to use comma. So execute it now. Now you can see. There are some errors. We'll see what are the errors. Okay, human message has no length. So we are using a function called length. Where did we use? Here. It is telling it is not having a length, len. Okay, so for that, RRRS request dot state dot get messages, messages. We are getting the messages. Okay, we are getting the messages of messages, but that is not required. Let me do one thing. I will write a function like this. Okay, then we no need to have this. Put this len of RRRS request dot state dot get messages. Then this one, this one, this one, 1, 2, 1 bracket, 2 brackets, then this one. Then finally close this. And here you need to use that double quote, right? You need to end it. Let's see if that is working. Okay, I applied like a function. Yes, we are good. Okay, so let's apply this as a function so that you will have that length function. So these are Python syntaxes. Okay, so go here equal to then this one of 1, then you need to 1, then you need to close this, then put double quotes, ending, and remove 1. Is it ended properly? No, right? Then this one is 1. Okay. But this length is not required. Why do we need length? We don't need length because we are not calculating the length. So therefore request state of, we can use this one because there is no length function, right? We can use straightforward like before. Okay, so now let's execute it and see. I think so far no errors, right? There are errors. Why we are getting again this? Okay, length is not required. Okay, so request dot state of messages of -1 then this one. Let's execute. That is just a typo error. Okay, now you are good. Yes, everything is working fine. Everything is working fine. Now you can see the results once, please. Now you can see the results once, please. What are we trying to do? We try to create the agent. The agent is already having middleware information. Now you invoke it. Whenever you invoke, okay, so whenever you invoke, the middleware gets called. Now it will come to the middleware. Okay, so in the middleware, we are trying to display all this information. You can see you are trying to display all the information. Okay, we try to display all the information. Current message, tell about ChennaRRRS in one line. Tell about ChennaRRRS in one line, current message. Like this we displayed. Then there is an actual call. You can see actual call. After actual call, you are displaying the response. Okay, actual call. You can see there is an actual call. Then you are displaying the response. You can see this is the response. That response we are returning back. That response. Okay, so we are returning back. It will come to this. That we displayed. You can see messages. You can see messages. That's it. Okay, so like this, there is a Tavily search also in between, right? Tavily search also in between. So it will go to the Tavily search and bring it. So like this, we have the execution flow. You can see here, please. So this is what you can also see in the nodes. This is what you can also see in the nodes. Okay, so request type, so on, so. Then maximum tokens, that this and all, human message, what it is going, tell about ChennaReddy, RRRS, and agents like this. Then you are getting the model response. That model response also we are displaying. Then here we displayed the list of the messages. You can see list of the messages. You can see list of the messages. That's it. So actual call happened. After call, you have the response. Actual call, you have the response. There is one more call, right? Two times will be their call. So you can see messages. This is one AI message. This is another AI message. So this AI message, once a tool call is done, there is a model request, right? Once a tool call is done, there is a model request. You remember the previous conversation? Once a human message is ready, so this is how it is, right? So if you see these messages, we discussed all these things before. How many model calls are there? Two model calls, right? Okay, let's say this is the model. This is a model. Now there is a human message. Once a human message is ready, there is a request one. Okay, this is the request one. Okay, request one. Now model model try to identify what are the tools required. Now if you go on to see, this one, it should have the tool information. What is the tool? Tavily tool, right? So what is the tool? Tavily tool. You can see tool calls. Tool calls, you can see. There is a Tavily tool. So you can see there is a Tavily search tool. So that is what it is calling. Okay. So that is what it is calling. That's what this one. So Tavily call got executed. That tool got executed and you will have the response. Once you have the response, once this completed, then I told there is a request to the model. There is a request to the model. With what? With the prompt and tool information, tool completion information. Now what this will do? This will do summarization, all these things, put all the information in the next AI message. That means two requests are there, two model requests are there. So that's why you can see two times it got printed. Two times it got printed. Okay, two times it got printed. Two times it got printed. Two model calls. And so on, so on. So this is how you can interpret or you can intercept. Okay, model. Intercept the model call. Before model call, after model call, using at wrap model call. So that means around the model. Around the model, that means before the model, after the model. If you want to do something, you can use this. Before the model, after the model. If you want to use something, then you can use this. That's it, that's it, that's it. Now let's see the end-to-end flow. So this is the end-to-end flow. So this picture is very important. Can you see this one, please? This is the end-to-end flow execution. Okay, so you can see the steps, please. First, we have written the code. Yes, we have written the code, Python code. Then we loaded the environment variables. We loaded the environment variables. That's correct. Then we initialized the LLM. That's also correct. We loaded the libraries and initialized the LLM. That's correct. Then we have written the wrapper model. Okay, so wrap model call. That means we have written the middleware. That's also correct. Flow. Now what that middleware is doing is explained here. Next, we have created the agent by passing the middleware. We created the agent by passing the middleware. That's also correct. Then we have a invoke method. We have a invoke method. That invoke method, what it will do? Okay, you can see invoke method. Invoke method means, okay, invoke method internally calls this middleware. So it will go to the middleware. So it will go to the middleware. So in the middleware, what do we have first? We displayed all the information before calling the model. So before calling the model. Then what do we have? There is a handler which calls the actual model. Which calls the actual model. Then we got the response. That response we displayed. That response we displayed. Okay, sorry. There is a agent runtime. So that means once you call it, agent runtime, agent messages. Okay, so once you call the model, you can see this, right? Once you call the model, then model will decide, are there any tools? Model will decide, are there any tools? If no tools, then that is the final output. If there are tools, right now Tavily tools are there, right? You can see. Right now Tavily search tool is there. So that is the one get executed. That is the one get executed. And keep the response in this tool message, right? Keep the response in the tool message. That is the one it will take and go and put in the response. So once that is completed, okay, once that is completed, now you will get the response. Okay, you will get the response. You can see. Then once the response is ready, we have done some logic. Line number 29, 30, like that. Okay. Then we are returning that response. Okay, we are returning that response, final response to what? To the agent invoke, and we displayed it. And we displayed it. This is a complete flow. And we displayed it. That's why we are able to see these messages. Okay, at high level, there is an invoke that calls the model request, then handler, agent runtime, then model, if tools, execute the tools. If no tools, then that's the final execution, then return the response, then after model, what to do, then come back to the invoke, returns the response. That's about this one. And these are the key points, what to do, what to not to do. And this is the end-to-end flow also. You can see summary of the flow. First configurations, then invoke method, model middleware before. So that means before model, then handler, then agent runtime, then tools are executed, then handler completed. Okay, then middleware after model, then agent invocation finishes. Like this, we have different steps also. This is how you are going to get the notes. This is how the final flow also mentioned in the notes. This is the excellent execution flow. You need to understand, you need to play. So the requirement is what? The requirement is I want to log something when agent get created during model or before model, after model. If you want to do before model, after model, what to do? we discussed it completely. That's all for today. If you have any questions, go ahead and ask. Else, we'll continue in the next session. Thank you.